Now that the Tesla Bot's second generation version was shown off last week, we've got a robotics expert here with us today to share some Easter eggs, some more clarification of the weight reduction, the elbows, and the walking speed. And he'll also share his forecast for how many Tesla Bots will be made and when they will be working in the factories. Scott Walter has founded 2 robotics companies in the past and has been closely following not just the Tesla Bot, but all the other robot companies out there. Welcome, Scott. Appreciate you joining me.
Yeah, guten Abend aus Deutschland, Herbert. Glad to be back on my trip over here, and I've had time to think a little bit more about that video that was released last week of the Generation 2 bot, and maybe some of the things we missed in our hot takes, and some things we could be looking forward to in the future.
So just for folks to know that Scott and I have been doing many videos, mostly on the Tesla Bot, but we've also covered many of the other robot companies out there. And then last week, when the Tesla Bot second generation was dropped, I had to wake up, tried to wake up Scott from his trip because he's on vacation right now. And so this is kind of the view of what's happening with the Tesla Bot. And if you can see, watch here, it was quite impressive. Everybody was really blown away at how incredible this new version is. You can see that it's walking faster. It's supposed to be 10 kilograms weight loss, and it's got this incredible new dexterity with the hands. That's the critical thing. And it's got the finger sensors now. So Scott, based on this video, what is it about it that you thought you want to dive deeper in?
Okay, well, first of all, that video was released at about 2 a.m. my time. Which is why I wasn't able to do that late night hot take. And we went through and we looked at some of the things. So, we noticed that the walking speed was improved. Obviously, we noticed the weight reduction, the addition of some of the sensors that are on there. And I've had a chance to look at them a little bit closer to get an idea of what's going on. And the first question I want to ask you, Herbert, is like, okay, it's they lost 10 kilograms, but how much does it weigh?
Right. And so let's take a quick look at this. Here's my understanding, right? So they lost 10 kilograms. And when we compare it to the previous version, we all assumed it's because they're using some sort of plastic covering now.
Right.
And they shaved off, like everything looks just thinner and quieter. But yeah, I don't remember how much it weighed before.
Yeah, well, see, we don't really know how much it weighed before. We know from the original specification that they want it to be 125 pounds. But that's from AI day 1. And we never really knew what the Generation 1 bot weighed. And back last spring, I was rather interested in figuring that out. And okay, have they been able to hit that target weight of 125 pounds? So I tried to figure that out myself. And fortunately, there was a slide that came from AI Day 2 showing all the different actuators. And next to the actuators, not only was it the amount of force or torque they could produce, but how much they weighed each. And like, well, that's good. So I know how much each of the actuators weighs. And we also know the number of actuators and where they're all going to be. So I was able to go through that map and add all those things up. And then I said, well, then I had to figure out the battery pack. And I figured out the size of the battery pack. And I was able to determine that it's 2170 batteries. There's 140 of them. And the whole mass of that is going to be about 9.2 kilograms, something like that for that amount. And started adding everything up to see if they were anywhere near that ballpark of 125 pounds. And I was a little bit above that. I was like, well, maybe it's about 130, 135 pounds. But I had to make a couple of guesses here and there with some things. So I wasn't quite sure how good my guesstimate was. And then I compared it to the other robot manufacturers that are out there and what they were. So for instance, I think the Boston Dynamics bot is about 200 pounds. So it's pretty heavy. However, Digit is more like around 150, and some of the others are also aspirational, somewhere in the 125 to 140 pound area. So it's like, okay, it could be right around there. There's probably some room for improvement. But they lost 10 kilograms. Now, if they lost 10 kilograms and it was already, let's say, at 130 pounds, that's 22 pounds it would have taken off. That means it's like 108 pounds. That would be really light. And I think that it probably weighed a little bit more than that. And right now, I'm pretty sure they have hit that 125 pound target. The question is how much they've gone below it and whether it's going to be a featherweight class bot or whether it's going to be a bantamweight class. Okay. I'm pretty sure it's already featherweight right now. Because when I was looking at it, my original estimates with everything in there, the actuators themselves weighed a little bit over 40 kilograms. I think it was like 41 kilograms. But now they just added 2 more actuators for the neck. So it's like, ooh, and those actuators weigh a little bit over a half a kilogram each. So it's like, whoa, they just threw in 1 more kilogram in actuator mass. So they're kind of going in the wrong direction. So where are they taking everything away? And I was looking at the whole thing, it's like, well, if it weighs about 60 kilograms and I've got over 40 in actuators, another 10 in the battery pack, that doesn't leave 10 kilograms to get rid of. Unless you're taking it away from the batteries, which they're not, and unless you're taking away from the actuators, which they probably are. And remember, Elon said lighter and tighter. So I suspect a fair amount of that mass, maybe half of it, was taken away from the actuators. And then probably the other 5 was taken away from the actual structure of somehow reducing the mass of structures, either with a different material, like within plastic, or maybe just manufacturing them in a way to be lighter. So there's not as much material there to begin with. I tried making an estimate that, I actually asked Grok for this. It was rather interesting, and I get it right. That I said, if I have 2 meter long pole of aluminum, that's 50 millimeters by 50 millimeters, how much does it weigh? And Grok got the answer right, about 13 kilograms. So I was kind of using that to get an idea of how much aluminum you would need in the overall structure of it. And so they might have had 13 kilograms right there. You take away 10, it only leaves you with like 3. And I don't think they were using 13 kilograms to begin with, because that's kind of a solid mass of aluminum that you'd be putting in there. So it's going to be coming from a bunch of different areas that they managed to reduce it. And it may have been that, cabling is also one area. I mean, there's a lot of cables that are hanging out on those things, and a lot of cabling can get pretty massive after a while. And it seems like they've been able to reduce the cabling, the harnessing a little bit, and they may have been able to save like a kilogram or something like that. So many places they've been able to bring it down. And again, the question was, how much does it weigh? They're not telling us how much it weighs. I'd like to know how much it weighs. It's nice to know that you dropped 10 kilograms, but 10 kilograms from where? So that was like the first thing. And then going along with that, do you have any more questions about the mass itself, Herbert, before we switch?
No, I mean, it is brilliantly thin now. And so, like as we know, Tesla is not only trying to create a functional robot, they're trying to make it so that it's easily scalable at cost. And they can make millions and millions of this. And you can see this version, they can make millions and millions of this. This is ready as far as I can, just by looking at it. It looks so refined already.
Absolutely. Absolutely. And part of it is that they didn't just reduce the mass of certain parts, they eliminated parts. Okay. So in that image there, we can take a look at the pelvis, and the pelvis used to have a front section and a back section. If you remember the belt buckle, that was in the old one. Well, that part of the pelvis is gone, as well as the connecting components that went between the front and the back. And they figured out, we can just make it out of one piece of material. So in other words, it's half of what was there before. So they, really changed the part quite a bit. And again, they say the best part is no part. And so they decided this particular part of that part we don't need, it's gone. And again, if they've changed materials, that's going to not only reduce the mass, but might make it a lot easier to mass produce. So if they are injection molded parts, those are really easy. You can just pump them out so quickly, as opposed to if you had to make a casting or something like that. So again, your production, your scalability is going to be incredible when you do that. So the next question I have for you is, what else did they improve by a certain percentage?
Are we referring to the torso?
Well, we could be talking about the walking, or if we want, we could look at the torso, because that might be.
I'm sorry.
Yeah.
Well, why don't we talk about the torso first? I see what you're saying. Yeah, they reduced the weight by 22 pounds, but they also increased the walking speed by 30%. Yes.
30%. Right.
Yeah.
So the walking speed, and again, it's like, 30% increase in the walking speed. The question no one asks is like, well, how fast is it now? Because we don't really know how fast it was before. So we know that aspirationally, they don't want it to be faster than 5 miles per hour. Okay. So they haven't really said that they want it to be 5 miles per hour. Guarantee it won't be faster than that. So you can run away if you have to. That's basically been Elon's promise. So long as they don't exceed 5 miles per hour, they can be good. But do you need it to go 5 miles per hour? Well, generally not. Now, a lot of the other manufacturers out there have spec sheets as well. None of them have hit, say, 5 miles per hour walking, except maybe Digit has, or Agility with some of their walking prototypes before. But some of them have even spec'd only about 3 miles per hour. And that's because that's really all you need for a walking robot. 5 is really brisk. I mean, very few people walk at 5 miles per hour. You almost have to get into a jog to be able to go that fast. So if you were doing useful work or anything like that, 3 miles per hour is more than enough. And even then, that's very quick on what you would need for most. You can go slower than that. So right now, what is the speed? And from what I could tell,
calculate it? Because I remember you actually calculated the last video. You had actually measured the way. What is the speed, Scott?
Yes, and so I looked at it several times by kind of by counting the number of steps it did, looking sort of at the size of the feet to get an estimate of the distance that it traveled there, and it looks like it's traveling probably about 15 feet in a little bit less than 8 seconds. So it's probably got a walking speed of, I think, about 1.5 meters per second. And that's going to be probably just shy of 2 miles per hour. It's going to be right in that area. Before, it was probably going maybe a meter a second or a little bit faster than that. And if it's able to go like 1.2 meters per second, then you're already at a good speed for being able to work in a factory. You don't really need to go faster than that. So a lot of times when we are doing our simulations and we are specifying how fast our humans, our virtual humans, are walking around, usually it's like 1.2 meters per second is what we assume. 1 meter per second if they're carrying something. So normal walking speed would be something like that. And if you're able to go 1.5, that's great. So it's right about where you need to be for working in the factory. So if it's a little bit shy than that, 30%, maybe it was 1 meter per second before, now it's 1.3, but I think it's a little bit faster than that. Still, not 3 miles per hour, which I think they will get to eventually. And once you're there, then it's like, wow, you can do just about anything in the factory. I don't think you need to go 5 miles per hour. There will be people that would probably like it for certain tasks, but I really don't think you need to go much faster than that.
But at this speed, you think that what they have now, at that speed, it can already be useful in a factory?
Right, exactly. And like I say, when we are doing our simulations, we're assuming 1,200 millimeters per second is human walking speed. That's, and
can I ask you a question?
We're talking about 1.5.
I want to ask this question much earlier than I wanted to, but I'm most curious about it. Is many people are saying that, this is great, wonderful bot demo, but it's not ready for the factory, not for a year or 2 years from now. What is your estimate of what you saw now? Could this be useful today? Is it being used in a factory today? Is that your guess?
It's being used probably in a demonstration purpose. I'm not sure if they're using it yet in like true production kind of scenario, because if they did, it may have leaked. We would have heard something about that. But I'm sure they are testing it in a variety of different applications. All the low-hanging fruit we're talking about. It's more than ready. The last one was already able to do some of the tasks. Not the ones. Maybe not some of the other ones that would have been a little bit higher than the low-hanging fruit. But this one for sure is able to do quite a bit of operations. The only question is whether it's able to do it reliably enough without maybe falling over, having all these issues, and whether they're able to put it through a full 8-hour test and having no issues. I don't know if they got there, but I think they're really close. And we will probably find out by next quarter. And it could be they've done a lot of these things, but they want to save some stuff for AI Day 3. When it comes around. So I expect by the first quarter. And now Elon has been, let's say, trying to sandbag or keep the expectations down a little bit, because when he talked about back in June that they only had, about 10, he said at first he was like, oh, there's like 5, 10 if you include, the ones that are in various states of disrepair and being put back together, and they're making about 1 a month. So we know that the numbers for the first gen were pretty small and probably never exceeded 24 or something like that. And they felt like they could do the training with a much smaller set than we had expected. And we expected they needed at least 100 bots to be able to train, but they probably felt with simulation we could do a lot of that, and we want to refine it before we really start scaling up. The other thing he talked about is that the Tesla designed actuators wouldn't be ready until November-ish or something like that. And at that point, they would sort of be in a state that they could start doing mass production of it. And of course, that's probably probably the major limiting factor on the bot. It's not going to be the casting and that. It's not going to be the batteries. They got more than enough batteries. It's not going to be the FSD chips. It's really going to be the actuators. And while the actuators are sophisticated, they're not going to be that difficult to mass produce once they get that line up and going. And so the question is, do they have that line scaling? And they probably have something. And it's a question of how quickly they want to like ramp it up to get it to start producing. So you're going to start seeing numbers that in the first quarter, which are probably going to start being the dozens in the first quarter, just to be able to prove it and then to start going out and doing real useful work in the factory, as well as testing and training. And then I'm sure once they get to a certain point, they hit an inflection point, they'll just start to take off. So I'm sure by the end of the year, they will be able to have hundreds of these produced, maybe a little bit more than the hundreds, because it seems like it would be something you could scale. And the only reason they wouldn't is because they've decided there's still something wrong with the design.
End of the year, you're talking in 2 weeks?
No. I'm talking about the end of the next year, because I'm thinking 2024. So the first quarter, that you probably start to see at least several dozen of them that are being used different places. Elon has said they expect it to be doing useful work in the factory sometime next year, which he meant 2024, and I absolutely believe that. And I think it'll probably. Again, he might be kind of sandbagging and being very cautious because he's on an earnings call and everything else, just really to make sure that any forward-looking statements are like, oh yeah, in January, it's going to be affecting margins already. So I would be surprised if they didn't have it by June doing useful work. I don't think we have to wait till December of next year that you would be seeing it doing something like that. Now, this is one of the first things I said when on AI day one. And that is, I know Elon says prototypes are easy, production is hard. But when it comes to humanoid robot, the prototype is hard, but the production will be easy. I've always felt, nice. I said, oh yeah, they'll be able to produce it pretty quick. So, the question is, do they need a Gen 3 before they decide to go into mass production, or are they going to be happy with this? Now, they will need a Gen 3 when they go outside of Tesla, when, they're starting looking something more general purpose. I'm sure of that. But for what they need inside the factory, it's ready to go. And a lot of the reasons it's ready to go is, I think, it looks very cobotic to me. So I'm not sure how much involvement, OSHA would have in this idea of this, this bot being used and being, working near people, where they have taken care of all the pinch and poke points that are in there, because it certainly appears that they have. So the coverings that are on there are very good. A lot of the areas we were concerned about as being, a pinch hazard, that, if your finger gets in there, it will, get broken or sheared off, depending on what's going on. You want to make sure that doesn't happen. As well as there were a lot of protrusions, things that were just kind of poking out that are kind of poke hazards. And that was one of the things about the elbow mechanism. The original elbow mechanism is it really had something poking out there, as well as something that was a really bad pinch point. And I sort of joked that, Optimus is one bot that you don't want elbowing you. You probably don't want to play hockey with him. He'll be a bit nasty. But now we see that we get kind of the elbow guards that are on there, and it's covered up pretty well, that you don't have to worry about those hazards anymore. And the few that you might be a little bit concerned about, I think, can also be covered up very easily with some sort of very simple fabric covering. But they've done a lot. We talked a little bit about it last week. Like in the wrist, what they did is they didn't change the kinematics anywhere. The only kinematics they changed is that they made the head move, so they added a little bit there. But the shoulder works the same way. The elbow, I've decided, is still working the same way. They didn't change it up on us and cover it up at the same time. The wrist mechanism works the same way. All they did is they refined it. And the one refinement they made in the wrist mechanism is that if you look at those two actuators, rather than those actuators being parallel to each other, they're kind of slanted a little bit. They have a little bit of a taper towards the wrist. And that means the linkage mechanism that was between those two is they're no longer so far apart, but it's a little bit closer together. And that means, well, now your wrist is a little bit more slender. And it'll be a lot easier to cover that up and everything else, as well as being able to get into, different positions that might be normally inaccessible. It'll be a lot easier. And then, of course, the hands, well, whole new set of hands there with the sensors. The pelvis looks very different. Looks different, but kinematically it's the same. So they change what that pelvic girdle looks like, but again, it's the same actuators stacked in the same way that they were before, same degrees of freedom, same kind of movement that you had before. And those actuators look definitely lighter and tighter to me than what they were before. So we talked about how big the buttocks was before. It really stuck out before. Now it seems like it's definitely way more compact. And we can see it in this movement that it's using everything. The hips are becoming a good part of the walking gait, along with the arm swing and everything else. And then throwing the foot in makes the walking even better. Rather than being flat-footed, we now have that nice heel-toe kind of movement that has allowed them to get that 30% improvement in the gait. And I'm sure they're going to be able to get a little bit more out of it as they improve the kind of movement that they have.
Yeah, okay. So let's take a look at this is the previous version, Gen 1.
Yes.
And because they've definitely slimmed it down. You're talking about, you don't want this thing to be elbowing you.
Oh,
Look
yeah.
how crazy this was. This was not ready to be, be used anywhere outside of the lab. Mm-hmm. And then I was saying that when I first saw this, I was just shocked at how incredibly the torso was fixed. So here's the new version of the WOP, much cleaner elbows, less torso. But you're saying this is actually the same mechanism, right? They just looked a little cleaner now.
It looks different.
They changed it.
And it looks very odd because of the shape of the torso. So the Gen 1 torso was a little bit tapered as you get down towards the waist. And because of that, you didn't notice how thin the waist really was, that there was just that spine that was being holding the whole mechanism up.
Gotcha.
Now it's a much squarer kind of torso. And I ended up in a post overlaying the two so you could see that. Now, the reason why I noticed that it was so different is that I visited the Tesla showroom in Zurich, and it turns out they had a Gen 1 robot there. And I was looking at it, and then I realized, oh, yeah, I forgot exactly how that waist taper is in there. So you can sort of see, when I superimpose the two, how thin the original torso is. And the new torso seems to be a bit bigger. And I'm wondering what they sort of changed up and why they changed the design. Now, there's a couple things they've done. Up on the shoulders, if you look at the original shoulders, those the servo axis for the shoulders are absolutely horizontal in the Gen 1. They go straight out. And that was something I didn't like. I was hoping they would angle them up a little bit. And if you look at this one now from the torso, I suspect what they've done is they've taken the actuators there and they've given it a little bit of an angle. It seems to be about an 8-degree angle from what I measured. I was hoping it'd be a little bit north of 10, but it's probably okay. So you can see the top of the torso where that black line is that goes down there. You notice it's not a vertical line. That it has a little bit of angle to it. It's about 8 degrees. That's a better way to mount the arms onto a torso, because when the arms are straight out, you avoid what's known as the polar singularity, or sometimes referred to as Codman's paradox. And so I prefer them doing that to avoid that issue. It's definitely covered up nicely. It's the same sort of serial linkages. But the strange thing was getting down onto the elbow, because in the elbow, the interior part of the elbow, you notice there's a lot of fabric there. There's a lot of that black fabric. I'm like, okay, what's it covering up? What's so important in that interior part of the elbow mechanism down around there, that rather than having hard plastic around there, they've decided to do that? And I was wondering, did they change the elbow mechanism? And so I was thinking, looking at this, and again, these are some shots from the Gen 1. You can see exactly the protrusion that kind of comes out, the poking hazard you're getting from the elbow, and how that mechanism is there. And you see that inner patch, that big black patch that we can see in the middle image there. And what is it covering up? Mm-hmm. And I thought maybe they had switched the whole mechanism around. And then the more and more I look at it, it's like, no, they didn't. And for some reason, they decided they wanted that to be opened up. And could it be because a lot of the cable is being routed through there? And usually with a cable going through there, you don't want some hard plastic where it might be rubbing up against and adding a little bit of additional friction. Another could just be for cooling, that you do have actuators in there, and you might want to allow a little bit of airflow to go through to keep them cooled. But I'm pretty sure it's the same elbow mechanism. And we can sort of see it's a little bit hard, but when you're looking closely, you can kind of convince yourself that the protruding part that is the poking hazard is covered up by the hard plastic shell on the lower arm, just enough. And then they put a little bit of fabric kind of covering around there just because you're going to have to do it. And you can see when the elbow is straight that it pretty much closes up. Everything is in there. So I'm pretty sure it's the same mechanism. They just packaged it up a little bit differently. And then, of course, they're doing a lot to make sure the cabling is not exposed. But at some point, you still have to run some cables through your different joints. And that's probably the reason for them coming up with that. So I had been flip-flopping where they had changed the mechanism. And I'm like, nope, I don't think they changed it. And they just maybe made some slight modifications to how it is. But it's mainly what they just had to do in the covering. And that was the best way to solve that issue. Could be a little bit of weight reduction, but that would be kind of ridiculous saying, oh, we want to cut out a little bit of this really light plasticky material. It doesn't weigh a whole lot to begin with. But then again, Sandy says, I want my engineers always find like a gram here and a gram there to reduce the mass in something. And maybe they said, hey, this is another way to reduce a gram.
Yeah. So huge improvements in Gen 2. You found the difference between the weight reduction, the walking speed, the elbows, the torso. And let's show a little bit of
now
an
the
Easter
torso.
egg.
Now the one thing on the torso, before we get into that, is what I'm just kind of wondering is that they just changed the shape of that a little bit. And I'm wondering, did they do that to add more batteries? Did they increase the size of the pack? Maybe a little bit, that's possibly. Or did they change the type of battery? And so I want to go through that train of thought because, like, okay, if they change the shape of that a little bit, did they decide instead of using 2170s, are they going to use 4680s? And I think there's a couple of reasons they are not using a 4680s. One is I think the 4680 supply they need to keep for the Cybertruck. There's plenty of 2170s, but right now I don't think there's enough supply. The other is I don't think the 4680s actually have a better energy density than the 2170s yet. So that means if you're trying to get the same number of kilowatt hours out of that thing, it might actually weigh a little bit more. And remember, they're trying to reduce weight, and they did reduce a little bit of weight. Right now, the 4680s only make sense from the energy density at the pack level. When you go ahead and create a module and get those things in there and use it as a structural component, and you don't really need to use it as a structural component in Optimus. So I'm pretty sure they're probably still using the 2170s. They just may have decided to come up with a different way of organizing them in there. And again, they're using probably the version 4 FSD chip and a few others, moving the electronics around. And there may be different types of cooling that they're using. I think someone said they might be using some sort of liquid to help with the cooling. So I know they definitely have fans in there, but internally they may be using some liquid to try to cool some of these elements out, which means you need to radiate it. So there could be a whole bunch of reasons. I don't think they changed battery types, and definitely they would not be using like LFP batteries because that's even worse energy density. It's just going to weigh a lot more, and you're going to have fewer kilowatt hours. You would only use LFP for stationary storage, and definitely not for something that's mobile, and not something like Optimus where you want to make it as light as possible.
Okay. And then for Easter eggs here, so one of the things that you noticed was this second bot. And one of the things you said was the tether's no longer grabbing it from the middle of the head. Used to be that you could, it was an empty head and there was like basically a metal hook that you can take a hook and carry the bots through the inside the head. Now it looks like it's being hooked to the back.
Back on the shoulders. Yeah, it looks like they probably have two attachment points for the lanyards back in the shoulder area, and able to clip on. And the reason they're not doing it from the head is that then all the weight is going to go through those actuators, and those actuators are really designed to be able to hold the mass of the neck and not the mass of the whole thing.
Then
and
what's inside the head now? What's inside the skull?
Well, imagine that, that's where they have the cameras, audio, and anything else in there. So it might still be empty. It may not be a whole lot. It's just obviously the neck area is filled up a little bit. And again, my suspicion is that for the roll of the wrist, the actuator there was the smallest of all the rotary actuators, and it was only used there. And it's like, well, wait a minute. Why did you come up with an actuator for just one particular thing? They are probably using that same actuator for the neck because it's the smallest one. Okay. And the neck does not have a whole lot of payload.
And then the second Easter egg, let's play this clip and tell me what I'm looking at.
Okay, and right there, oops, if we just go back there for a second, we can see that on the left side, there was an Optimus that was being kind of partially assembled. And it turns out there's another one on the right side that's also being assembled. And that's something that was pointed out by a couple of people to me in post. Claudia Mole from John's channel, she pointed that out, and that there is basically 3 Optimi in that image.
What? How?
One way over on the left, the one that's walking, and the one that's on the right. And we all saw the one on the left. That was obvious. We all missed the one on the right. I shouldn't say all. I missed it. Maybe you missed it, and the rest of us when we were going over it. However, everyone else there in the Tesla community,
what do we see?
Many of them noticed that.
A head and a torso?
Yep. Yeah, we see a torso. And if we do a close-up on the back, I wondered where the e-stop button went, because it used to be right behind the neck. And all the images we had of the bot walking from behind, we could not see. I was looking, say, wait a minute, where's the red e-stop button? You can't see it there, and I don't see it on the back of that. But it looks like in the where it's being assembled, there does seem to be a red button when you zoom in really close. So when you get to it, at some point in there, if you zoom in really close down towards the middle, so it almost would be at the small of the back. Yeah, so it's sort of like at the small of the back. Effectively, on there seems to be something that looks like a red button, but that seems to be a strange place for it, and it may be covered up so you don't notice it when it's walking around. But the whole point of an e-stop button is to be quite visible and for everyone to be able to see it.
Okay, that's great Easter egg. Anything else that you found? Anything else that's kind of closer look? Now that you spend a little bit closer look.
Yeah, so let me think. We talked about the weight reduction. We've talked about the torso. We've talked about the speed. And I think the other question that kind of comes up a lot is that everyone's been saying, well, I would say, there have been some people that have been questioning whether the bots would be able to have a useful lifetime in operating, whether they could really go 8 hours in a charge. So the feeling is like, oh, there's no way they could do that, that they require too much power and everything else. And you need to push back on it, because the first argument is that, well, wait, just the compute alone is just going to, there's no way you could get that much out of it. And let me remind you, it's like everyone was saying, oh, Elon is using laptop batteries to make cars drive. To build the Teslas, and it's true. Like the 2170 is a laptop battery, right? You have probably one of them in your laptop, or some laptops have that, and it's enough to keep your laptop running for a couple of hours, right?
Yeah.
Now, a laptop is like a really inefficient operating system on there called Windows. It's got foreground processes and background processes and like all this other stuff that displays is managing, and it just despite that fact, that little battery will keep your laptop running for a couple of hours, depending upon what you're doing. If you're doing something really intense, it'll go down. FSD, that whole thing is absolutely optimized to use the minimum amount of power necessary, and it's not running all these silly foreground and background processes that I generally like to call bloatware, because a lot of them are just inefficiently written. All the stuff is written well. They're not using a whole lot of power. Now, if, usually your laptop can run an hour with doing intense stuff, maybe watching a video or something like that, or doing some number crunching or something like that. They can do like 6 to 8 hours usually in some sort of kind of background or very simple kind of operational mode. Okay, use one of those up for each hour, a 2170. That means you need 8 of them to be able to run your laptop for 8 hours, right? There's 140 in there. There's 132 in reserve, okay, to do other stuff. The other thing I want you to think about is that the Optimus battery pack is 1/30th of a Model Y's battery pack. 1/30th.
Okay.
1/30th, okay. Using that calculation, there's enough power in Optimus to propel a Model Y at highway speeds for 10 miles. Okay. The other thing is, remember the actuator that was picking up the grand piano? They showed that, and there is a video out there.
Oh,
yes, right. Yeah, so there's a grand piano, and it's a half-ton grand piano. That means 500 kilograms, and it was lifting it up. Okay, and it was lifting it up, somewhere around 2 inches, something like that. And it would take about 2 seconds to do that. How much power do you think is required to lift that grand piano? How many watts do you think is needed?
No idea.
I mean, it seems like a lot, right? It's only like 183 watts at the speed that I'm guesstimating. I'm just going less than 200 watts for it to be able to do that. Okay. That power pack has enough power in there to basically continuously lift that grand piano for about 12 hours.
Wow.
Okay. That one
Wow.
actuator. So now Optimus is not lifting grand pianos all day long.
Yeah.
Just lift it. There's enough energy in that battery pack to take that grand
Wow.
piano and lift it a total height of 276 meters. Okay, going at that rate of about maybe an inch a second or something like that. So you might think there is nowhere near enough power in the battery pack to be able to have to go for 8 hours, and it's like, yeah, there is, and it's pretty clear that that for 8 hours, like no one works all out for 8 hours. It's like you've got a little bit and then you slow down a little bit, you slow down. So it's more of the it's more of the tortoise versus the hare. If you're going to put it in the hare mode, 4 hours. Tortoise mode, 8. And then there's the other thing is there's always the possibility that depending upon what the operations are, it could be charging while it's working.
Continuous charging, yeah.
If it's stationary or semi-stationary. And again, that's the thing I say about my laptop is like, hey, when I'm mobile with my laptop, I get a couple hours out of it. And when I'm stationary, I plug it in. Okay, it doesn't matter.
Yeah, Jay Leno just did an interview with Franz and Lars about the Cybertruck. And Franz, who's the chief designer for Tesla, confirmed that Tesla is working on wireless induction charging. So this is the ability for the Tesla car to drive over a mat, and without hooking any, cords in, it'll just automatically charge. And they had bought a company called Wiferion. They resold it, but doesn't mean that they still kept the technology. And he's confirmed they are still working on it. And so this allows a bot to stand on a mat, and that mat will constantly give it energy, power. So it can work 24 hours a day.
Yeah. It definitely could. And there are other inductive means of charging. There's a company in Quebec that's working on it that's, rather than using inductive charging, is also using that's more of a capacitive type of charging, using electric fields. And they've come up with a novel approach, and you don't have to be that close to the charging pad, which is kind of amazing. And they are getting, I think, also a high 80%, 90% kind of efficiencies out of it. So I was really surprised. I met them about 2 months ago here, and that's also something to kind of look at, the possibility that you don't have to be actually standing on something. It's possible that you might be able to have something that you're just standing next to, and it would be literally charged to the torso. So you don't have to worry about, needing a charging pad or anything like that. So there are other technologies that could be used for doing something like that. But even short of that, the battery packs will be able to get you that much. Now, the other humanoid robot companies out there are not having the same kind of, let's say, some of them are saying 1.5 to 3 hours or 5 hours or something like that is what they're targeting. Some of them, they don't really say what they are, but their battery packs are much smaller. So very few of them will tell you the size of battery packs, but you can look at the torso and say, where's the batteries? There's not enough room for the batteries in there. And they're usually around, one of them listed at 864 watt hours, or in other words, less than a kilowatt hour. So maybe a third of what you're seeing in Optimus. So along with the fact that Optimus has a much bigger battery pack, very efficient actuators, the battery management system and everything else in there, they will definitely be able to hit the 8 hours. There's
And they
no doubt
lost
about
22
that.
pounds.
And they lost 22 pounds. And the other thing we haven't even looked at is, like, I've also wondered whether they're going to use any sort of regenerative type of braking in there. So it's like, if you go up there and you bring something down, it's like, it's like, are you able to use that as an opportunity to charge? You never know. And I don't know whether there's that many opportunities when you look at how a worker is working versus a car, slowing down or something like that. But there's always a possibility too, that you get a little bit of regeneration.
Interesting. Very cool that you found all these Easter eggs. I knew that you are the kind of person, and you've done it for so long, you would do close-ups. You'd really try to understand. You finally got the things you were asking for. You pointed out before in the past, it used to be flat-footed. Now it's got the toe ability to do that.
And it has the toe box that's able to now flex. That's one of the things we wanted to see. Also, the sensors down in the foot, just to make sure that you get your balance a little bit better. The expectation that you needed to have both of those things. A little improvement up on the shoulder, the packaging that they did with the cables. The sensors in the fingertips, I think they kind of surprised. I thought they were going to get away without it. It was tempting to say that, oh, they should have the sensors in the fingertips or not have them in there. And this is, of course, Elon's algorithm. You take out, parts until you've taken out so many, you need to put some back in. So they really wanted to see, do we need to have the fingertips in there? And they do. And from what we can see on those sensors is they're at least on the tips. We don't know about the middles of the fingers. The sensor array seems to be a 6x6 sensor array. And it seems to have about 8 levels in there. So it would be, and John Gibbs reminded me because I forgot my binary arithmetic. It's 3 bits of precision, basically, because it looks like the color that they were showing from black up to the hottest number. It seemed to be about 7 or 8 steps in there if you look at them really closely. And definitely I could see a 6x6. I was expecting an 8x8 grid just because it's a nice binary number. But so a grid of 36 elements with precision from like 0 to 7 levels, and probably enough precision in there, as I've said, that you could probably read Braille. So it would be sensitive enough to be able to do that. Wow. And of course, the sensitivity they need to be able to handle any sort of object. That on top of what they probably already figured out from the back EMF and the force feedback and everything else that's going on in the hands. I think they probably have a really good set of input data to train off of now for being able to do any sort of very delicate kind of tasks, to the point that they're expecting sometime next year to be able to thread a needle, which will be quite impressive.
Right. So you did say that by sometime next year, it should thread a needle. So Scott, come on, take a look at this bot, right? It's so impressive at how sleek it is. They lost the 22 pounds. It's so designed. You've talked about how it has the Tesla logo on it, but the fingertips are so impressive. I mean, this is just, you don't put a fingertip on a prototype or something that's just being used in a lab. I mean, this is being tested now. Yeah.
And in much better hands. We notice responsiveness is much better. So it's not just that they have the sensors on the tips. The hands are much faster. Remember before they were kind of slow, but now it's like, the movement it's exactly the movement that you need for being able to do operations on the floor. So, if before it's like, well, why haven't they been using it already in the factory? And it might be that it was just too slow. It wasn't that it was walking too slow, but also it was just too slow with the hands. And now it seems to be much faster. And part of that's mechanics, and part of that could also be the AI. The end-to-end is allowing them to make decisions faster.
That this video was not sped up. This is a 1.0 speed. So what? Look how fast it's moving. Its wrists, its hands, its fingers. Okay.
That is very good speed.
Yeah. My thinking is that, I know you've been a lot more conservative now. You're saying that,
I want to be proven wrong, but for the right reason this time. That's why.
You're trying to be more conservative. I'm actually the opposite as you, which is, I'm going to be much more aggressive now than it was last year. So when we looked at the very first bot, and we were trying to figure out how much, we were saying, hundreds need to be done by the end of the year. And it obviously didn't happen, right? It was only, only just 10s or 20s. But the reason is because of the actuators. And then Elon said that by November, it's now December now, but by November, we expect to have finalized the actuators. And that once we have it finalized, we're going to do it at scale. That's what he said. So it wasn't just, we're going to need to finalize the actuators. He said that this is now going to be ready to build at scale. That's what they're doing. Now you see this sleek bot, and it looks like the actuators are finalized. They look
I think so.
finalized.
I think so.
Okay.
I think they've got what they want.
Ready to build at scale. Now, I predicted 2 weeks ago, I said that I believe there's going to be a Tesla bot demo dropped in December. And it happened within the week after I said it. And the reason I said that was because you did not hear them talk about the bot in the Cybertruck event. You didn't hear him talk about it in earnings call. And so you knew that there's a reason why he's not doing it. He wants to save it for the actual demo. And it shocked us. Okay.
Yes.
And the same thing's going to happen. And I know you just said that I think we need to wait for AI Day 3 to happen, which is going to happen in the first quarter of 2024, in the next 3 months. I believe there's going to be another demo every month. He's already mentioned that before. We should really drop a demo every month. And so the next demo that they drop will be showing the bot at work. It will be showing it using work, because what you see now, like, how do you top this, right? We've got this incredible bot, looks fantastic. It can walk faster and reduce shape. We got the fingertips now. The next demo has to show it. It's physically working in the factory.
Right. We've seen enough of it sorting blocks and doing stuff like that. That was all very nice. If
So
we want to see it doing a real task.
Yeah. The last demo before this demo was, well, let's go back. First, you had the demo of Optimus 1. You saw that big, giant, hunking thing, and it could do stuff. It was walking, right? Then the second demo they did before this last one was its brains. It can now sort really fast. It can identify its hands, spatial. It can really know, it can understand if a block fell over. You didn't need to teach it. It just learned it through video. Then this demo was back to the hardware. So the next demo has to show it working in a factory with its improved, its intelligence to learn and intelligence to act.
Yes.
So
yes,
I think it's going to happen in the next 3 months, that demo that it's working in a factory is already happening. And I think that by next year, okay, I'm not going to call, I'm going to say less than 1,000, but still lots, like more than hundreds. And because it's already at scale, and they're going to want to have that many working in the factories.
Yes.
Yeah. So you know what I mean? Like, I know people are being so conservative right now, and I'm like, why are you being conservative now? You should have been conservative, like it's the opposite. Every time you see the progress so much faster, why are you being conservative at this point?
And I think it's because this time, if we're going to be proven wrong, we do want to be proven wrong for the right reasons, and that they've been able to scale it up pretty fastly. And I think part of it is also just that, Elon has been a bit more tempered in his language on that. Maybe, they're really sandbagging and he's just going to surprise everyone. It's still kind of a conundrum for me on why we're not seeing more, and that when it happens, it's probably going to just be like that. That once they get it working in a couple of stations, they could be getting it doing a lot. My feeling is that they would probably go after the S and X lines for now, because it's lower volume and it's not going to be as disruptive of trying to bring a bot in there to do it. And it may be that there's a lot of things they haven't automated yet in the S and X lines, remember, because there's like really no reason for them to do it. I think it's a very manual line. So they may have more opportunities to go in there and use Optimus for it to prove itself out. And then that's where you get like what I call the absorption rate, is that you have to make sure that you have enough places that you could absorb 1,000 bots if you're going to produce 1,000 bots. But if you only have like a dozen or two places that we know it can actually function, then you're only going to need that many bots. And then you're going to have this plethora of other bots sitting around doing nothing. So that might be the reason that they aren't scaling, because they're trying to identify them. But I think there's a lot of them. I really think there's not one low-hanging fruit. There's lots of hanging fruit out there that they could be going after really quickly.
My other thing, okay, so is the hardware a rate limiting step? At this point, you're the expert.
Nope.
You saw this.
Hardware looks like it's not a rate.
Okay. Is the brains the rate limiting step? It could possibly
be. It could be that they're not quite there yet, but they're close. Could be very close.
Okay.
The only thing we don't know about the hardware is the reliability of it, and like the walking. That can it walk back and forth for 8 hours without falling down? Is it falling down every 20 minutes or something like that?
Yeah.
So and maybe there's a little things like that they're trying to work out, that they want to say, wait, we got to get the reliability up to a certain point, and then we can start doing it. But I suspect right now it might be more that they don't have everything going yet with the AI, but they're close.
Okay, so I agree with that, right? So there's still definitely rate limiting steps, and this is not going to happen right away. Having said that, I just want to step back and think about it. If you're Tesla, what is the biggest product that you need to work on that's going to have the most impact to your entire business? If you throw all your might, all your money into Dojo, which is the intelligence, the brain, the power of the bot, and make the bot useful, as fast as well, even if it's just a year ahead versus, a year later, the impact to your business is just tremendous, right? Auto gross margins, the sales it's going to offer. This thing's going to impact every business. We're talking solar, we're talking Megapack, we're talking like every business you're ever at. So I'm just, it's a priority. It's not probably the top priority. So you're gonna throw everything at it. Anyways,
you are. And as we can see, that there's a team of at least 100 people involved. So it's not like a little skunk works. It's like, yeah, we're serious about it. And we've seen the job listings that are coming out there. There seem to be more for getting ready to ramp up the production technicians that'll be working on it for training the Tesla bot. So yeah, I think they're getting to that phase that right now they're ramping, and we're just kind of not sure, like, when are we really going to see this? But it's probably going to just surprise us.
And the job listings also identified jobs required for 24 hours, like midnight graveyard shifts. Mm-hmm. So they want people working 24 hours on this.
Yes.
Yeah. So
absolutely.
Thank you so much, Scott. That was fun. Mm-hmm. You pointed out, as you always do, after a bot demo, you always dig deep and find all these things. You can't help yourself.
Yeah.
And you find all these Easter eggs, and you learn more. So thank you for doing that.
Okay. Yeah. Thank you, Herbert, and Merry Christmas to everyone, because I have a feeling this is probably going to come out on Christmas Day, maybe.
Yeah. Thank you so much, Scott. Talk to you soon. Bye-bye.
Okay. Yep. Bye now.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.